Welcome to Next Gen Manufacturing. Today, we're diving into a world where innovation is measured in microns, and speed is absolutely everything. We're looking at how these incredible cutting-edge tools are shaping our future, from the rockets that take us to space to the tiny medical devices that can save our lives.
So that brings up a really fascinating question, right? How does a company that's been around since the 1930s not just, keep up, but actually lead the charge into the future? It's this amazing story of legacy meeting innovation. So let's dive in.
To really get where manufacturing is going, you've got to look back at where it all started. And this story begins not just with a company, but with one single revolutionary material that completely changed the game. Okay, picture this. It's 1938. A metallurgist named Philip McKenna founds a company, but he also invents this groundbreaking tungsten titanium carbide alloy. Now, this wasn't just some small tweak. It was a total game changer. It let machines cut super hard metals at speeds that were just unimaginable before. And then just 5 years later, the company becomes Kennametal, really cementing its place as an industry pioneer. And wow, the ripple effect of that one innovation was just huge. All of a sudden, these tools were critical for pretty much everything. In the cars we drive, the planes we fly, the buildings we work in, and even the power plants that light up our cities. This company's DNA is literally woven into the fabric of the modern world.
But, innovation doesn't just stop. The industry was about to see another massive shift, moving away from the raw strength of the tool itself to the power of what you could put on its surface.
And you can really feel that moment in this quote from the company's VP, Scott Eatling. He talks about a product called KC550, which became the absolute industry standard. I mean, it was everywhere. It was a huge success, but it also kind of represented the peak of that old way of thinking, right before the next big thing happened.
And you can see that leap perfectly right here. The whole game changed. Instead of just relying on a solid piece of strong metal, the focus shifted to developing these incredibly thin but ridiculously powerful surface coatings. It was like going from building a strong brick wall to creating a super thin diamond-hard shield to put on the outside. This was the secret to unlocking way higher speeds and efficiency.
And that leads us right to a perfect modern example, Kengold's technology. It's this complex multi-layer coating that gives tools incredible wear resistance. But get this, the gold color isn't just for looks. It's actually a super clever visual cue that lets machinists literally see when the tool is starting to wear out. It's so simple, but it's brilliant. And here's the bottom line, the so what for the customer. As Scott explains in the quote, these coatings create a total win-win. You can either crank up your machines and run them faster to get more done, or you can keep them at the same speed and your tools will just last way, way longer. Either way you slice it, you're saving money. All right, now we're gonna zoom in, and I mean way in. The next frontier is all about micromachining, and it's all packed into a new platform called the TopSwiss MBS. So TopSwiss MBS stands for Micro Boring Solid. What this thing does is solve one of the biggest headaches in manufacturing. How in the world do you machine super tiny parts with insane precision inside a really tight space and still get a perfectly smooth finish?
Okay, get ready for this, because this is the whoa moment. This system can machine a hole as small as 0.3 millimeters. To give you some perspective, that's less than half the thickness of your credit card. We are talking about a level of precision that is almost impossible to wrap your head around.
So who on earth needs that kind of precision? Well, the industries that are literally building our future. We're talking about the tiny, tiny parts inside a life-saving medical implant, or the super intricate components in a satellite's guidance system, or advanced sensors in our cars. This tech is what makes all of that possible. Okay, so beyond that amazing micro tool, there's a whole lineup of new gear, and each one is designed to tackle a specific modern problem. Let's do a quickfire round and check them out. First up is the Harvey 2 TE. This is a 5-flute end mill, and it's basically designed to do two things at once: cut through material incredibly fast for maximum productivity, but also be tough enough to last for a long time. It's like having a sprinter's speed and a marathoner's endurance all in one tool. Next, we've got the KCU25B turning inserts. And hey, you should recognize this tech. They've got that same KNG gold coating we talked about earlier. This makes them unbelievably durable, especially when you're working with really tough stuff like stainless steel or high-temperature alloys. And last but not least, the GoMill Pro. The real genius of this tool is its shape. It has something called an asymmetric flute design. Now, that sounds super technical, but here's what it means in plain English.
It's designed to stop the tool from shaking. And the result is a much smoother cut, a better finish, and way less stress on the machine itself.
All right, so we've seen all this incredible new tech. Let's zoom back out for a second. What does this all actually mean for the people who are using these tools every single day?
Well, it really just boils down to 3 huge benefits. First, higher productivity. You make more stuff faster. Simple. Second, longer tool life, which means less time changing out tools and, of course, lower costs. And third, greater precision, which gives manufacturers the power to create these incredibly complex parts that just weren't even possible before.
And really, that brings us to the final big idea here. Every one of these innovations, from the smart coatings to the microscopic tools, they're all enablers. They push the boundaries of what's possible. And that just leaves us with one really exciting question to think about. With tools this advanced, what are we going to build next?